The broadcast is now starting. All attendees are in listen-only mode.
Okay, hello everyone. Hope you're all doing great. And before we actually begin our today's tap room, I would really like to make sure that everyone can see my screen and everyone can hear the sound. So could you please drop the message into the chat box so I'll be 100% sure that I pre-configured all the stuff. Okay. Okay, that's great. So our today's topic will be basically instructions for connecting the iSCSI, Microsoft iSCSI initiator in Windows Server 2012 R2 while doing the Starwind configuration. So basically this is the very hot topic because we have, like, if I'm not mistaken, about 30 to 40 of overall cases just being published due to misconfiguration, due to some minor mistakes when configuring Starwind storage, and mostly these mistakes has been done by configuring this iSCSI initiator. So I would first of all introduce myself. So yeah, my name is Vlad, just Vladislav Kariv, my full name. You can call me Vlad. So I am solutions engineer at Starwind, basically doing some pre-sale stuff, recommending our customers the best way of configuring Starwind, of deploying the virtual infrastructure, consulting on multiple topics, not only just about Starwind, but in Starwind with VMware, Starwind with Zen, Starwind with Microsoft, how they cope together, how to better deploy the physical part of the infrastructure, to configure networking, and many, many other interesting stuff. So you can find me on pre-sale. And without any further ado, let's actually RDP to our test environment. Today we have not our regular Dell 730s, but this is just the simple configuration on top of some custom-made PCs with Core i7, 32 gigs of RAM, and a couple of SSDs and SATA drives, so nothing really fancy, but still this configuration is not storage or compute related. It's just the must-have, and basically we can just use our test environment today. And let me quickly show you our Starwind Management Console. So as you can see, we have already 2 portals discovered in iSCSI initiator, and now we'll just remove them for now, so we will have the clear picture and work everything from the very beginning. Okay. It says VMware localhost because this environment is actually virtualized on top of the VMware, but still, it doesn't matter in this case. So we have a couple of already created devices, 3 data stores and 1 storage device, 5 gigabytes. Yeah, not sure why we have created this, but still. Let's create the new device. So we're using Add Device Advanced Wizard. As I always recommend, it just gives you much more options to configure the actual Starwind device. So they're a very basic setup basically. So we're starting from choosing the hard disk device, virtual disk, specifying some name. Let's call it test, or not even test, but tap room, room, yeah, tap room device. 1 gigabyte would be pretty much enough. 4K block size for Windows. We do not need any caching here, so without level 1 without level 2 caching. Create a new target called tap room and creating the device. Now we will replicate this device using the replication manager. Adding replica to our partner server, which is VSN2. Now we're going to specify the networks, and as far as I remember we have 20 subnet for synchronization and 10 subnet for iSCSI connections. So yeah, as I have been told before, so we usually recommend to configure heartbeat on top of iSCSI networks as well. So not only for the management network, but for iSCSI network as well, because that's not the type of network which utilizes a lot of traffic, so we can place it on as more networks as we actually want to. So it will give you just extra redundancy. Now we're clicking next and synchronizing from existing device. Now let's see what we have here. Okay, let's give it a bit more time. Spam refresh button. Okay. So here they are, two parts of the one HA device. Tap room here and here, they are pretty much the same size and the same settings. So obviously this is the HA device. And now after we have actually created this device in Starwind Management Console, our next step would be somehow presenting this device to the Windows. And in order to do so, we are obviously need to connect those targets in iSCSI initiator. So yeah, we have some favorite targets already. Let's remove them. Let's keep everything clear. Okay, some connected targets. Let's disconnect them. So at this point we have nothing configured in Microsoft iSCSI Initiator on the node 1, on the VSN1. And at this point we're actually starting the iSCSI configuration. So in order to be able to connect to multiple targets or to the single test target, we will still need somehow to discover them. So in order to do so, we're discovering the portal. First of all, we need to discover the local server, because obviously we have this multipathing, and we will need, as well as local connections, we will need a partner connection. So let's connect the local server just by specifying the loopback IP address. Choosing Microsoft iSCSI Initiator here, and leaving the initiator IP address as the default, and pressing OK. So there are actually many questions regarding should we specify the exact IP address or not, in this case an IP address in the setting. And I would say it's not really necessary, because usually we have separated networks, especially for Starwind, so we're not recommending to mix Starwind networks, iSCSI and synchronization with any other traffic, including management, some backbones, LAN, probably some backup networks. So we really need some clean and segregated just for Starwind networks, and in this case we have 1 gigabit adapter just dedicated for this type of network, for iSCSI network for Starwind. So right now we are discovering the second portal, and it would be our partner server's iSCSI IP address. So I'll quickly show you how it looks like on the second server. Okay, so we are remoting to VSN2. And basically, as we have a 3-node configuration and we are now only working with 2 nodes, we have these 2 to 3 and synchronization 2 to 3 networks unused at the moment. So we're right now only using the synchronization network and iSCSI network. Synchronization network is the network which we have specified already when replicating our newly created Starwind device, and this one is iSCSI 2 to 1, which means going from the second server to the first one. And let's just double check the IP address. So we have 172.16.10.20 for the IP address, and that's the exact IP address which we need to specify on the VSN1 on the first host. Okay, so we have typed in the iSCSI IP address of the partner server, choosing the local adapter as Microsoft iSCSI initiator, as well as on the previous step. While connecting the local targets and initiator IP, we will leave it by default as well. We are pressing OK button, and right now we should be able to see every single target on both servers because we have discovered the local portal and the partner portals. So let's find our newly created device. Okay, here it is. So this one is VMware localhost taproom. It really sounds like the local target because we have added this device, this local host by this VMware localhost host name. That's why we see this name here, and we'll connect it properly. So we'll use just the loopback IP address in order to connect this device. So we are pressing the connect button. Also, just to remind you that I would never recommend to use this, where it is. Okay, my iSCSI initiator hang out a bit. So yeah, there is auto configure option, and this is the option that you that you're not going to use because it can mess up the whole configuration. It can mess up passes between each other. So I would always recommend just to configure all this stuff manually. Okay, so we are going back to this local target, pressing the connect button, enabling multipath, pressing advanced, choosing Microsoft iSCSI initiator here, and here I recommend to specify the exact IP address. So in our case we have this 1010 IP address for iSCSI network on the first host, because it would be our initiator IP, and for target portal we are using the loopback IP address. And failed. Okay. Oh yeah, sorry for that. So as we are connecting the local target, we do not actually need to specify the exact IP address in this case, initiator IP. Yeah, that's my fault, sorry for that. So we are leaving this value as default, and for target portal IP we're specifying the loopback IP address because we're just connecting this target locally. And now it should work. Yeah. Now we will find out the second device, which is the target located on the partner server VSN2, pressing the connect button. And here we actually need to specify the exact IP address here for iSCSI networks. So initiator IP address would be 1010, server 1, and target portal would be 1020, I believe. Let's double check. Yeah, 1020. We're pressing OK, and we have finished pretty much the half of this configuration. We're finished configuring the iSCSI initiator for this newly created device on the first server. Now, in order to finish configuration, we need to go back to the second server and basically replicate all of these settings in Microsoft iSCSI initiator here on the partner host. Okay, it's acting weirdly. Well, yeah, sometimes this guy's initiator hangs out and it's pretty much normal behavior. Okay, so it is perfectly clear on this node, and we can begin connecting the, discovering the local portal as well as the partner portal. So we're doing the same, specifying the loopback IP address here, choosing microservice as initiator again, and pressing OK button. And yep, let's give it some time. Okay, finally. And here we need to discover the IP address of the first host correspondingly. So it would be 172.16.10.10. So we're only using iSCSI IP addresses here, so no management networks, any other stuff, only iSCSI IP addresses. Choosing microservice as initiator as well, and pressing OK. And after that we can see the whole list of targets and our device which we need to connect. So given that we are working right now on the VSN2, this target VSN2 taproom would be our local target, so we will connect it just locally via loopback IP address. So we're just specifying the microservice as initiator and loopback IP address here, and pressing OK. Okay, it's done. And this one, VMware localhost taproom, is the target on the partner server, which is in this case, this is the VSN1. So we would like to connect it using the iSCSI network. So in this case, the initiator IP would be this local VSN2 server, which is 1020, and partner would be 1010 for VSN1. We are pressing OK, and it hangs, and it's done. Yeah. And it hangs again. Okay. So yeah, that's not really critical issue for us. Let's go back to the VSN1, and I'll show you what actually will happen after you have finished the iSCSI configuration. So after that, as you have already connected this device using multiple passes, by default it's round robin, so two servers can see the passes to each device on each other. And basically we can see the newly created device in disk management now. Yeah, so this would be the disk 2. Let's cancel automatic partitioning and just observe what do we have here. Okay, we still have some 1 GB device here as well. Let me F5 this. Okay, which one is what? Let's go back to Start Management Console just to make sure that we do not have any extra devices connected, because usually we should see just one virtual drive connected after finishing iSCSI configuration. Just to be exactly sure that we are working with this particular device, let's somehow mark it. We'll mark it by just extending it, so it would be 10 GB. So I just wanted to extend this device just to see the difference in disk management and actually to locate the proper device. Well, yeah, that's strange, because we have somehow two virtual devices available, which is not really correct. So Probably we have connected something wrong in iSCSI initiator, so let's just double check and apply necessary changes. And yeah, that's it. We didn't install actually the MPIO role on this server. So let's do it. Okay guys, could you please confirm that you can hear me and you can see the picture, because I really have some technical difficulties here. My laptop just fails on me. Okay, that's great, that's great. Now let's go back to the VSN1 and actually install the MPIO features. So in order to do so, we need to go to Server Manager. Now we're going to okay, let's wait a bit. Okay, yeah. We're going to add roles and features menu. Skipping all with the default values and going to features and ticking this multipass IO button. Now we can click next and install. So after this feature will be added, it will ask for restarting the server. As far as I know, it's not really obligatory to restart the server just after this multipass installation in order to make it work. So we will try to do it without restarting the host, just to save our time. We're pressing close, going to MPIO, and here is the important step. We need to actually tick this option, add support for iSCSI devices, and it will actually trigger the restart, but no, we won't let it to restart. Okay, now let's go back to iSCSI initiator and check the MPIO to actually work properly. In order to do so, we need to disconnect and reconnect devices, because obviously they have saved the previous changes. Let's remove them from favorite target lists. Okay, and let's try to connect them in the same manner as we have already done, but we just need to make this MPIO feature to work. So this one is the partner device. Okay, we have finished connecting the partner device. Now let's make sure that MPIO works. Let's try to install MPIO on the partner host as well, because it may actually be the problem. We are going to Server Manager as well, doing the same stuff, installing MPIO feature. Multipass IO, clicking Next, and waiting until it actually installs. Okay, now we can go to MPIO Manager and add support for iSCSI as well. I'm not going to reboot this. Also, let me just tick this option one more time, because I just pressed OK the last time and not the add option, which needs to be pressed actually. So once again we need to press this add button, clicking no and OK. Okay, and right now actually MPIO should work properly. Let's double check on the VSN2 on the second host. And it sees two active passes, loopback one and iSCSI network. Now let's go back to VSN1 and try to discover this hard disk actually. Yeah, okay. So here it is finally. Sorry for this little inconvenience, because I was sure that MPIO was already enabled and it wasn't. Yeah, it happens sometimes. Anyway, that's the good practice of troubleshooting general issues with Starwind, so it's not really critical. Let's put this device online. And press initialize as GPT. And basically that's it. Now we can create a new simple volume. This volume actually does not need to have any letters, because we will later add it to fill our cluster, because it would be our cluster shared storage. We will format it as an TFS, call it taproom, pressing next and finish. And at this point, this device basically is already added to disk management on the partner server on the VSN2, but it's offline and it's okay. So after you have configured the device in disk manager on one of your hosts, you can actually create the cluster and add this device as the cluster shared volume. So basically that's it. That's how to configure the iSCSI initiator. And really, if you have any questions, like any concerns about this whole procedure, you can just shoot them out right away onto the chat box in GoToWebinar, or to this questions thread, which we have already opened. So I have already several questions. First one from Iskren Petrov: does multipassing increase throughput? Well, yeah, basically in round-robin mode, that's actually why. Let's actually begin from the very beginning. So we have several technologies for increasing the overall throughput of your networks. You can combine several networks by using NIC teaming, for example. But NIC teaming is not really reliable for some specific products. Also, as far as I know, it's not the most reliable solution, speaking about this iSCSI storage. So it can play fairly good when you team in your networks for live migration networking, for example, or for your LAN networking, or for something else. But for iSCSI storage, it is better to use MPIO. Basically, MPIO in round robin works exactly the same as a NIC teaming basically. NIC teaming increases the overall throughput when you add extra networks, and round robin works pretty much the same. The only difference is when, for example, you're mixing the different type of networks. For example, if we have two iSCSI networks, one 10 gigabit and another one just 1 gigabit, when we'll add them both in multipass mode and choose round robin, they will work with different throughputs. So it will not work with the overall throughput of 11 gigabit per second. It can work with the speed of the slowest one. So it will be like 1 plus 1 gigabit. So it will be like 2 gigabits in total. So that's not very great. That's why for MPIO you need to combine the networks with the same throughput. For example, networks for 1 gigabit networks in round robin would give you pretty much 4 gigabits of throughput for iSCSI storage. So that's how it works, and that's how it increases the throughput. Okay, so Roger has already thrown me a link to the Microsoft site when on this article about basically does Microsoft support iSCSI and NIC teaming. So yeah, I would say that Microsoft actually can support it, and they may support it, they can support it, but just from my personal point of view, from my experience, I do not really recommend to use it with iSCSI storage, not only with Starwind but with other vendors as well. Okay, let's go to another question. So in your, Curly Beratov asks, in your webinar and all your example setups, you emphasize that sync and iSCSI traffic should be on separate LAN VLAN pairs, but never explain why. Is it a requirement of Starwind or of the failover clustering, or just best practice? So basically you can treat as our like best practices, because when you are using NIC teaming, for example, when you use several combined networks, NIC teaming driver itself will create the overhead on each package translated between those networks. So for example, when you have just two hosts connected between each other and you are using a PIO, and let's say the overall setup looks like two iSCSI networks on each host. So using MPIO, you will get these 2 gigabits of throughput, but without any overhead. So packages will be translated just directly from host to host through the physical network adapter, and basically that's it. And when you are using NIC teaming, you may have up to 2 gigabits throughput as well, but NIC teaming software, NIC teaming driver will still have this extra overhead on each package, just to basically tell the physical adapter that those two packages are from the one network, so they should be treated as a single package. I don't know how to explain it like more advanced, but still, it creates more latency. It usually creates just more overhead in the overall system. So that's why we are not recommending it. Okay, let's move to another question. Okay, another question from Kirill as well. So question sounds like, if I have two 1 or 10 gigabit Ethernet connections per server, crossover no switch available, how do you recommend setting up multiple VLANs? So if you have two, for example, 1 gigabit networks, so okay, just to point out that if you have just two, for example, 1 gigabit networks, it's not really fits our minimal requirements, because we need at least two 1 gigabit networks just for Starwind. So probably you will need one more network for management, for LAN, for something else. So if you're telling that you have just two 1 gigabit networks for Starwind, that's pretty much okay, and I cannot actually recommend using VLANs, because why do you need them in this setup? So our best practice is actually very straightforward. So you'll just get some, you'll need to get some like separate network adapters and use them separately for Starwind. So dedicate them just for basically storage tasks. And in case if you need some VLANs, some advanced transporting in your networking, you can just add one more quad port NIC, assign teaming VLANs, anything. So another question from Roger, jumbo frames with 10 gigabit NICs or not? Always jumbo frames actually. Jumbo frames may not be like as well. This information just from my personal experience, and I really rely on it, and it proven to be working, so you can trust me. Jumbo frames are critical for VMware environments. I saw a lot of cases when not enabling jumbo frames decreased performance. Speaking about storage, decreased performance, gains some instability, which is not great. Also, VMware reacts really weirdly when, for example, you forgot to turn on jumbo frames on some part of your networking, and for example, you turned on jumbo frames on the first host and forget to do this on another host. In this case, it can just fail. It can disconnect the data store. It can do whatever it can, because really VMware is not the most stable thing to work with, not consistent jumbo frames. So from my experience, I usually always turn on jumbo frames as well as on 10 gigabit networks, 1 gigabit networks, 40 gigabit networks, on VMware, on Hyper-V, everywhere. So they usually give you this extra 10 to 15% performance just because you do not need to transfer 4 or 3+ packages of 1,500 kilobytes. So basically, jumbo frames, sorry, not kilobytes, but bytes. Jumbo frames just give you this like less throughput required to transfer the same amount of data, basically. How to test MPIO in Windows? Asks Dennis. So the best practice to test MPIO in Windows would be actually well, you can create the failover cluster, assign the cluster shared storage, and migrate your storage, for example, to the node 1, as well as virtual machines. You can migrate them on this on the node 1 as well. You can actually migrate the whole cluster to the node 1, make it the cluster owner node, and just shut this node down. And in case if MPIO is not working in your environment, there would not be any live migration or quick migration, so it will just, like, the cluster will fail. And in case if MPIO configured properly, you will see this nice quick migration or live migration, depending on was it the gentle shutdown or not so gentle, pulling out the power cord, for example. So that's the best practice to test MPIO. Also, you can test the performance of MPIO just by adding some extra NICs for synchronization, for example. You can see the network throughput just by pressing Ctrl-Del, going to the Performance tab and going to the Networking tab, where you will see the current throughput. So you can make your system, your Starwind system unsynchronized, for example. You can just shut down one host, boot it up, and check the throughput that is going between the hosts when they're performing this fast synchronization or full synchronization. And later you can add some extra network adapters and see if the speed has increased. Then basically, yep, it works, MPIO works properly. It gives you more throughput depending on how many more NICs you will add. So that's the case as well. Another question from Kirill asking, thanks for answering. Apparently you're recommended to add more adapters, but in your document, Hyperconverged Scenario Basic 2-Node Setup Manual, it says both Sync and iSCSI data use their own VLANs within 2 crossover connections between the servers. Well, yeah, sorry for that. Basically, we are working on our documentation. really shortly we will publish the new set of updated documentation when all of this like inconsistencies would be removed, and basically this document is a bit outdated. So I always recommend you to contact your sales representative, your pre-sale engineer, just like someone from our pre-sales department to actually advise you the best possible configuration. Because yeah, you can build it by your own. You can rely on our documentation, on our videos, but it really would work much better when you just ask our engineer to configure everything, and that's it. That would be the best practice, really. Another question from Ropish. What is the recommended speed? So as far as I understood, you mean the throughput for Starwind networks. And I would say it really depends on multiple factors, starting with your storage performance. So when we are speaking about this iSCSI storage thing, so we always facing some bottlenecks. And in order to actually find out the exact amount of networks, their throughput, you first of all need to calculate the physical performance, the performance of your physical storage. So beginning from the very bottom, for example, you find out that your RAID performance gives you something like 300 megabytes per second throughput. After that, you can be sure that 1 gigabit NIC would not be enough in this case, because 1 gigabit network adapter would give you just 125 megabits per second, if I'm not mistaken. So in this case, it would be great if you could add another 1 gigabit network. And in this case, you will have in total of 250 for the network throughput, and it can really work with your 300 megabytes per second storage. So that's how it's done, basically. So you need to check for bottlenecks. You need to test several setups. You can test basically what works better in your case. Should you connect your networks using round robin or failover only on the loopback interface? Does extra NICs really increase your performance? So it's really a matter of testing, I would say. Okay, trying to find any other questions. Well, looks like there are no more questions here. Okay, guys, please let me know just if you have any other questions, or should I finish this presentation right now? Because I really would like to answer all of your concerns. Okay, and I have another question from Maxim, and it sounds like when we do clean shutdown one host in 2-node cluster, it normally that we have error event 10 from iSCSI PRT. Well, okay, this error usually connected to iSCSI misconfiguration, to MPIO misconfiguration. Actually, in this case, I would like to recommend you rebuilding your cluster. So if you have such possibility, if there's this test environment, you can just rebuild your cluster. So you can I would say deattach, or how this function called, I just cannot remember exactly, but doesn't matter. So you're destroying your cluster, you're creating the new cluster on top of these two hosts, and you're looking through your validation report. In case if MPIO or iSCSI is not configured properly, all of these errors, all of these warnings would be in your report, basically. Because iSCSI PRT errors, I saw them a lot, and they're usually connected with misconfiguration on the iSCSI part. Okay, guys, so at this moment, as far as I can see, there are no extra questions. I really thank you for attending our tap room today, and yep, that's basically it. This webinar would be available on our website soon, so you will be able to see all of this iSCSI configuration stuff. If you did not like remember all of this, or you want just to review it one more time. So yep, that's it. Thank you again and have a great day. See you.